In this video, we're going to look at how mathematicians in the history try to search for the solutions of equations with higher powers, like third power, fourth power. And before we look at that, we're going to talk about some algebraic formulas we're going to use in this in the process of solving a cubic equation or quadratic equation. So first of all, we look at a plus b squared. A plus b squared, 2 here, the power 2 means 2 copies. So we're going to multiply a plus b and a plus b. And we use FOIL rule or distributive property. We do a times a, that gives us a squared, and a times b, that gives us ab, and we do b times a, that is ba, which is the same as ab, and plus b times b, that's b squared. And we combine like terms, we get a squared, and ab plus ab gives us 2ab, and plus b squared. One thing we need to be careful is a plus b squared is not equal to a squared plus b squared. It actually has a third term, twice of a times b. We do have another formula, but kind of similar to this, but it's for multiplication. In that case, we can do a times b times a times b, 2 copies of ab. And because of all the multiplications we have, you can switch a and b, commutative property, and we can get b times b, and that is equal to a squared b squared. But this formula does not apply to addition, so we cannot just distribute the power to each of them, each of the terms. But if it's multiplication, you can kind of distribute the power to each of the factors. So the formula is a plus b squared equals the first term, this is a, represents our first term, a squared, plus 2 times a times b. B is our second term, and plus the second term squared. So this is the formula, first formula. The second formula is going to be a plus b cubed. And we know a plus b cubed is 3 copies of a plus b. And of course, a plus b times a plus b, we have to do the first two, and we just gonna use the first formula. A plus b squared is a squared plus twice of the first term times the second term plus b squared, and times another a times b. So now we're going to have to use distributive property, a squared times a, that gives us a cubed, a squared times b, that's a squared b, and 2ab times a, that's 2a squared b, and 2ab times b, that's 2ab squared. Now we do b squared times a, that's b squared a, which is also ab squared. B squared times b, that's b cubed. Now we combine like terms, we get a cubed, combine these two, we get 3a squared b, and combine these two, and this is plus right here, so we get plus 3ab squared plus b cubed. So if you look at the power, it's the sum of the powers of the letters always is equal to 3. And so, for example, the first one, if there's only one letter a, the power is 3, and in the second term we have a squared and b, so the power of a is 2, the power of b is 1, so they add up to 3. And the next term, the third term, the power of a is 1, which is not written, is omitted, and power of b is 2, 1 plus 2 is 3, and the power of b is 3 too. So let's write down the formula of a plus b cubed, which is equal to the first term, a is the first term, b is the second term. So the first term cubed, because it's the third power, plus 3, the first term squared times b, and plus 3, the first term times second term squared. Remember, the powers add up to 1, and plus b cubed. So these two formulas will be used in the process of solving the higher power equations with higher power. So next we look at example. We're going to solve equation with the highest power equal to 3. So an equation that looks like this: x squared plus ax squared plus x cubed plus ax squared plus bx plus c equal to 0. So what we're going to do is we're going to use the reduction method. We reduce this equation to a new equation, y cubed plus py equal to q. Notice that in this equation, the highest power is still 3, but we don't have y squared. So we have the third term, third power, and the first power, y, but we don't have y squared anymore. But in original equation, we have cube power, second power, and first power. And so hopefully this new equation is easier to solve than the original one. But how do we get rid of x squared? Well, so this is the formula we're going to use. We always let x do a substitution. So we substitute y minus a over 3 for x, and if we plug this in there, replace x with y minus a over 3. After we use algebra, the formulas we just talked about, and we should be able to get this new formula, which p here represents expression of letters a and b, and c. So we're going to use an example to look at this case. So we're going to write down example: x cubed plus 20x equals 6x squared plus 33. Now we're going to use reduction method. So what we're going to have, we're going to do is use the method x equals, we do a substitution. But before we do that, we're going to change the equation to the standard form, which means when you move everything to the left side, so we subtract 6x squared from both sides, or you just move 6x squared from the right to the left, which will change positive to negative, and plus 20x, and move 33 to the left, so equals 0. So this is the standard form, which matches the equation here. So notice that a is the number in front of x squared. So let's take a look here. The number in front of x squared is negative 6. So when we do the substitution by looking at the formula, we let x be y minus a is negative 6 over 3. So we simplify this, we get y plus 2. Two negatives make a positive. So what we're going to do now is we're going to replace our x with y plus 2. So y plus 2 cubed minus 6 times y plus 2 squared plus 20x minus 33 equals 0. So we're going to use the formulas we just talked about. Y is the first term, and 2 is the second term. So use the formula. Let's take a look at the formula again right here. So we use this formula here. So take you can copy down the formula. So when we do the problem, you can look at the formula and apply it. So the first term cubed plus 3 times the first term squared and times the second term plus 3 times first term times the second term squared and plus the second term cubed. So here is a result by applying the formula, cube power formula. Minus 6, and now y plus 2 squared. Right here we're going to use the formula again. So the first term squared plus 2 times the product of the first term times the second term, and plus the second term squared, 2 squared, and plus 20x. Oh, I'm sorry, I forgot to replace this x here with y plus 2. So we also need to distribute. Get a 20y plus 20 times 2, which is 40, minus 33 equals 0. So next we're going to multiply out 6y squared plus 2 squared is 4, 4 times 3 is 12y plus 8, and distribute -6 to all of these. We will get minus 6y squared minus 24y minus 24 plus 20y plus 40 minus 33. Now we're going to combine like terms. We get y cubed and the 6y squared. Notice that here 6y squared cancels -6y squared, so we don't have y squared term anymore. So this formula right here, when we use it, we should always get rid of this. Has been verified, and it's a little tedious, so we're gonna skip that. But this, whenever you replace x with y minus a over 3, you should always get rid of y squared term, the second term. Okay, now we can combine the others. This y terms, and we combine all the constants. So you can use a calculator if you need to. So we end up with y cubed plus y cubed plus 8y equals 9. And this equation is much easier than the original one. So what we need to do is we kind of have to solve this one, but it's still not very easy to do. But in the homework, you should be able to solve it by factoring. In this case, it's not easy to factor this one. So I'm just gonna try to show. So suppose that we can kind of plug in numbers and guess that I have at least one solution, y equal to 1, and I plug in there, and because when we plug 1 in here, 1 cubed plus 8 times 1, it is equal to 9. So if we find out what y is, and we can plug back into the original equation right here, because x equals y plus 2, which means 1 plus 2, that's 3. So we get one solution for x. But actually, we know that if this is a third power equation, we should have 3 solutions. The reason we are missing the other 2 solutions is because we didn't really solve this final equation. We just kind of guessed an answer. So this is what they have in the textbook. But I'm going to kind of add something here. If you want to solve for the other 2 solutions, you have to do factoring. So that's what you have to do in the homework. So instead of keeping 9 on the right side, I'm going to move 9 to the left side, subtract 9. And this equation can be factored. I mean, this probably is hard for most of the students to factor. The homework problem is actually very easy to factor. You just have to factor out a greatest common factor. Over here, I'm just going to show you what the answer is, so you don't have to worry too much about it. So that's going to be y minus 1 plus y times y squared plus y plus 9 equals 0. So by using algebra, we know that we can get y minus 1 equals 0, or y squared plus y plus 9 equals 0, because if the product of 2 factors is 0, either the first factor is 0 or the second is 0. So from the first equation, we can get y equals 1 by adding 1 to both sides. That's how we get this solution right here. And but the other one is a quadratic equation, and we have to solve it by quadratic formula, which is going to be y equals 2 times a, which is the number in front of y squared, negative b, the number in front of y, plus or minus b squared minus 4 times a times c. That we actually get an imaginary number. So here, after that, you can plug back into the equation to get 2 imaginary solutions. But here, we're not going to worry too much about that. So you can use algebra to reduce it and plug back in there. So that's how we use reduction method to solve a cubic equation. And in the homework, this part will be much easier than this example, so you don't have to worry about imaginary solutions.